Hello everyone. In this video lecture we will begin with class 10th, chapter number 8, Introduction to Trigonometry, exercise number 8.1, question number first. The first question says as, given a triangle ABC with right angled at B, AB as 24 centimeter and BC as 7 centimeter, we have to determine the question in two given parts. The first one is sine A and cos A. The second one is sine C and cos C. So let's first draw the triangle for part 1. We have given us right angle and at B, and here we need to calculate it for sine A. So remember that with respect to which point you need to calculate, like here we need to calculate with A. So the A should be the adjacent angle for triangle ABC. The adjacent angle is the angle opposite to right angle of the triangle. So here this point will be A, so AB, and here C. Let's put the values given in the question as AB as 24 centimeter given, BC as 7 centimeter given. We can calculate the length of AC by using simple Pythagoras theorem, which says that the square of hypotenuse is equal to, here the hypotenuse is AC, base, the square of base plus the square of perpendicular. So we need to calculate AC. We'll put the values of AB and BC here. AB as 24 centimeter, and we'll put whole square of it to calculate AC, and the same goes with BC. We know the square of 24 is 576 and the square of 7 is 49. The sum of these two is 625, which is equal to square of AC. To remove the square from AC, we'll put under root add to this given value, and the under root of 625 is 25, as 625 is the square of AC. We got the value of AC as 25 centimeter for this respective question. So now we need to calculate for sine A and cos A. We know that for sine theta, theta here represents any adjacent angle in the triangle. The ratio is perpendicular upon hypotenuse. And for cos theta, again theta is the way to represent adjacent angle. It is base upon hypotenuse. You just simply need to put the values from this triangle in the form of ratio and you'll get the answer. For sine A, we have already taken adjacent angle as A, so it is perpendicular upon hypotenuse 7 by 25. You can see it. And for cos A, it is base upon hypotenuse, so the base is 24 and the hypotenuse is 25. So here we have calculated it for past. Solve it for first part. Sine A as 7 by 25, cos A as 25 by, cos A as 24 by 25. Let's continue with part 2 of the same question. We need to calculate for sine C and cos C. So let's draw the triangle again, because here we have given a different adjacent angle. Given that right angle at B, it will be same. We just need to change the adjacent angle, the angle opposite to right angle. So this will be the adjacent angle here, and point A we have mentioned. So the values for AB and BC is interchange with our previous triangle. So AB is now perpendicular and BC is base. We don't need to calculate again AC with Pythagoras theorem, as we have previously solved it. AC is 25 centimeter. Again, you know that for sine theta, it's perpendicular upon hypotenuse, and for cos theta, it's base upon hypotenuse. Theta is the way to represent adjacent angle. So let's put the values here. For sine C, we have already mentioned adjacent angle is C, is 24 by 25. For cos C, It's base by hypotenuse, so 7 by 25. We have easily solved the first question. I hope you got it. So let's continue with question number 2 of the same exercise. Question number 2 says that in the figure 8.13, question number 2 says that in the figure 8.13, the figure which I have already drawn for you, we have to find 10p minus cot r. This is the figure given in your book as well, NCERT. So let's continue with this question. So first of all, we need to calculate the value of RC. So first of all, we need to calculate the value of RQ. Again, we'll apply Pythagoras theorem in triangle PQR. The same hypotenuse square is equal to perpendicular square plus base square. We'll apply basic mathematics rule here. The square of 13 is 169. The square of 12 is 144 plus RQ square. We'll shift the value, we'll shift 144 on the left hand side, and here it goes. We'll get 25 when we subtract it, which is equal to RQ whole square. To remove the whole square, we'll apply under root to value of 24. So under root of 24 is equals to RQ, and the under root of 20. To get the value of RQ, we need to apply under root to 25, and the under root of 25 is 5. So we get the value of RQ as 25. So here first we need to calculate it for 10p. So here the adjacent angle will be p. So let's draw the triangle required for us to calculate 10p. This is Q. This angle should be p, as we need to find the ratio for adjacent angle as p. So here this angle should be p and r. Now we'll note the given values. RQ we have just calculated as 5 cm, PQ as 12 cm given in the question, and hypotenuse as 13 cm. We know that for tan theta, it is the ratio is always perpendicular upon base. So here for 10p it is perpendicular as 5 cm, base as 12 cm. Now to solve for cot r, now again we need to draw a different triangle as our adjacent angle has changed. Right angle Q will be same. Now this angle should be R and P. This triangle will be same as given in the question on NCERT. This will be 13 cm, 12 cm and 5 cm. And we know that cot theta, for cot theta it is always 1 by of tan theta, which means reciprocal of tan theta. We can simply for you people, you can simply understand that it as reciprocal of tan theta. So cot theta is equals to base upon perpendicular. Simply we'll put the values here. For cot r it is 5 by 12. Now we need to calculate the subtraction of these two both numbers, and we can easily see here the subtraction will be 0, as 10p minus cot r, tan p is 5 by 12 subtracted by again 5 by 12, will get the answer as 0. So let's continue in the video with question number 3 from exercise 8.1. The same we are doing. In this question it says that It is given as sine A as 3 by 4, and we need to calculate the value of cos A and tan A. It's a very simple and basic question. You just need to get the basic of it. We'll draw a triangle again, as we have given the ratio of sine A as 3 by 4. So it is very clear that the adjacent angle is 3. And we know that for any sine theta, sine is always perpendicular upon hypotenuse. So it is 3 by 4. So perpendicular is 3, hypotenuse is 4. Now by simply taking by simply solving by Pythagoras theorem in this triangle, let's name it as ABC with right angle at B. So we can get it as AC square plus BC square plus AB square is equal to AC is 4 square, BC AB we need to calculate, and BC as 3 square. 16 minus 9, as 16 is the square of 4 and 9 is the square of 3. We'll get AB square. 16 subtracted by 9 is 7, which is equal to AB whole square. But we need to get the value of just AB, not the square of it. So we'll apply under root to 7. So AB is equals to root 7. And if we solve for root 7, the value will make the question more complicated. So we'll solve this question simply with AB as root 7. Now we need to calculate cos A and tan A. So we know that for any cos theta, it is based upon hypotenuse. So here for cos A, it is base. Base is BC, that is root 7. We have just calculated. So cos A will be root 7 upon the hypotenuse given in the question as 4. So cos A is root 7 by 4. And tan A, for any tan theta we know that it is always perpendicular upon base. So here for tan A, it will be the perpendicular value is given to us as 3 and the base we have just calculated. So cos A is root 7 by 4 and tan A is 3 by root 7. Let's continue in this video with question number 4 from the same exercise. The question says that it is given that 15 cot A equals to 8, and we need to find the ratio for sine A and sec A. So first of all, it is given as 15 cot A, and we know that all these trigonometric values are ratios. So first we will get the ratio for cot A, and if we, and this 15 is in multiplication with cot A. So if if we take it to the right hand side, we will get cot A as 8 by 15 as the ratio. And we know that for any cot theta, the trigonometric ratio is based upon perpendicular, as I have earlier mentioned as inverse for tan theta. So now we will draw the triangle for this cot A, as it is given as cot A. So the adjacent angle will be A. The angle opposite to right angle is always the adjacent angle. A, B. So let's name this point as C for our convenience. Base is 8 centimeter. Perpendicular is 15 centimeter. We'll again apply Pythagoras theorem and calculate the value for AC. So let's begin it. So AB is 8, BC is 15. We'll put the values here. The square of 8 is 64. The square of 15 is 225. The sum of these two values is 289, which is equal to AC whole square. So again we'll apply the same thing we are doing from previous three questions. To get the value of AC, we'll apply under root to 289, and 289 is the square of 17. So AC is equals to 17 units, we could say, as there is no unit mention, no particular unit as centimeter, meter mentioned in the question. So we'll simply say as AC as 17 units. Put the value, the triangle we have drawn earlier, AC 17, BC 15 and AB as 8. We need to calculate for sine A, sec A. We know that for any sine theta, the ratio is perpendicular upon hypotenuse. We can simply put the value from our triangle ABC. So sine A is perpendicular as 15 and hypotenuse as 17 centimeter. 17 units. For sec A, for any sec theta, the value is always hypotenuse upon base, which is also inverse to cos theta. I have mentioned as 1 upon cos theta, which is equal to inverse of cos theta. I'll show you here. Cos theta is equal to base upon hypotenuse, and sec theta is equal to hypotenuse upon base, which is simply equal to, sec theta is simply equal to 1 upon cos theta. So now let's put the value for sec A from our triangle we have drawn as ABC. So sec theta is hypotenuse 17 centimeter and the base value is 8 centimeter. We got both the ratio as, we got both the ratios from this we got both the ratios asked in this question. Sine A 15 by 17, sec A 17 by 8. So let's begin with the last question we'll be solving in this video as question number 5 from the same exercise. It is asked in the question as to calculate the T ratios. T ratios is an abbreviation used for trigonometric ratios. You will find this term T ratios in good reference books as R.D. Sharma or R.S. Agarwal. So it is given as the sec theta as 13 by 12. We need to calculate the rest of T ratios. So we know that for sec theta, it is always equal to hypotenuse upon base. This question is a very easy question but lengthy. We'll do the same step we were doing from last 4 questions. First of all, we have written the trigonometric ratio given. We'll draw our triangle with the adjacent angle we have given. So here sec theta is given as 13 by 12. So hypotenuse is given as 13 and base as 12. We'll name it as simply A, B, C for our convenience. Always remember the point is for any right angle triangle, the hypotenuse is always the lengthiest of the triangle. And the hypotenuse always remember for any right angle triangle, the value for hypotenuse will always be greater than the base and perpendicular. Okay, so first of all, we need to calculate the perpendicular AB. So again, we'll apply the same basic formula we are applying from last 4 questions. These first 5 questions of this exercise are very similar. AC plus BC plus AB का AB whole square. AC square equals to BC whole square plus AB whole square. So AC we have given as 13, BC as 12 centimeter, and AB we need to calculate. 169 equals to 144 plus AB whole square. 169 minus 144 equals to AB whole square, which is equals to 25. So AB whole square is equals to 25 centimeter. Again we'll put under root to 25 and we'll get AB as 5 units. Sorry, not centimeter. A tip for you: for any right angle triangle, if the hypotenuse is 13, not compulsory the hypotenuse is 13, the set goes as always 13, 12 and 5. This is a bonus tip for you. As if 13 is the hypotenuse, the base or either the base or the perpendicular will be 12 or 5. Okay, now we need to calculate the rest of the t ratios in this question. So simply we'll put the values. Here we get AB as 5 units. For sine theta, we know that it is always perpendicular upon hypotenuse. The value of perpendicular is 5, hypotenuse 13. For cos theta, it is base upon hypotenuse. The base is 12 and the hypotenuse is 13. For tan theta, it is always perpendicular upon base. So perpendicular is 5 centimeter, base is 12 centimeter. Why I have first calculated for these three basic values as sine theta, cos theta, tan theta, because the rest are just reciprocal of these. Reciprocal of these will not do hard work here, will go with a smarter way. Okay, so I'll tell you, for sine theta, sine theta is the reciprocal of cosec theta. Cos theta is the reciprocal of sec theta, and tan theta reciprocal of cot theta. If you find this way of writing a way too complicated, I'll tell you the easier version as well. So sine theta, we know that it is perpendicular upon hypotenuse, and cosec theta is simply the reciprocal of it, that is hypotenuse upon perpendicular. So for calculating the rest of t ratios, we'll just reciprocal these three basic values. So let's calculate. For cosec theta, will be reciprocal of sine theta, that is 13 by 5. For sec theta, reciprocal of cos theta, that will be 13 by 12. For cot theta, reciprocal of tan theta, that will be 12 by 5. I hope you'll find this way a bit easier, not for this question, but later when we solve the complicated questions from this chapter, you will find this tip very beneficial. I hope you'll get each and every point. That's it for this video. We'll continue from question number 6 in the next lecture.